All right, let's talk about the next step for AI. We're moving beyond AI that just talks to AI that actually does things. Today, we're going inside a multi-agent system to see how it works.
We've all gotten pretty used to asking an AI to write an email or maybe summarize a document. But what if you could just say, hey, plan my entire trip to Tokyo for next week, find the best flights and hotels in my budget, and build me an itinerary? And it just did it? That's the huge leap we're talking about today, from a passive AI to an active one. So let's break this down. On the left, you've got the AI we know and use every day. It's a passive processor. You give it an input, it gives you an output. But on the right, that's Agentic AI. This AI doesn't just wait for instructions, it takes initiative. It can manage an entire workflow to achieve a goal. It's kind of the difference between an assistant who takes notes for you and one who plans and runs the entire project from start to finish. But here's the thing. For the really complex stuff, one super genius AI might not be the answer. I mean, think about it. In the real world, when a project gets tough, you don't just find one person to do everything, right? No, you build a team of specialists. And this multi-agent approach, it's a lot like smart software development. When you break a huge problem down and give the pieces to specialized agents, the whole system just becomes easier to build and way more flexible. Each agent is like its own reusable tool, ready to tackle its part of any big, messy, multi-step problem you throw at it.
Okay, so theory is one thing, but to really get this, we've got to see it in action. So today, we're going to pop the hood on a system that does exactly this. Let's meet Magentic One. This is an open-source system from Microsoft Research, and it's built from the ground up to solve complex tasks, things that need you to search the web, dig through files, and even write a little code. So here's the basic layout. Right at the center of everything, you have a lead agent, and it's called the orchestrator. You can think of it as the manager of a small, very specialized team. The orchestrator's job is absolutely crucial. It's the project manager of this AI team. It looks at your big goal, breaks it down into smaller, manageable steps, and then, and this is the important part, it figures out which specialist is the right one for each job, tracks progress, and course corrects if things go wrong. So let's meet this specialist team. You've got the web surfer, that's your researcher, an expert at digging up info online. Then there's the file surfer, who's the archivist, a pro with documents and spreadsheets. The coder is your engineer, writing Python scripts. And finally, you have the computer terminal, which actually runs the code. Each one has a very clear, specific role. And all this creates a really elegant workflow. The orchestrator makes a plan and delegates a task. The specialist agent goes and does its thing. The result comes back to the orchestrator, who looks it over, updates the plan, and figures out the very next step. It's this continuous loop of planning, acting, and then reflecting. Okay, let's make this real. Let's say you ask the system to find and analyze a piece of code. The orchestrator's first move is to tap the web surfer on the shoulder and say, go find me the URL for the quicksort algorithm on Rosetta code. The web surfer heads out, does the search, and comes back with the link. As soon as that link is back, the orchestrator reviews it and says, great, okay, coder, your turn. I need you to write a script based on the logic you find at that URL. The coder then gets to work, writing a clean piece of code to solve that specific part of the puzzle. And to finish the job, the orchestrator passes that brand new script over to the computer terminal agent who just runs it. And boom, there's your output, the sum of two elements from a sorted list. That's the final answer delivered through this amazing collaboration. One big task, perfectly broken down and solved by a team. So yeah, it all sounds fantastic on paper. But the real question is, how well does it actually perform? Well, the researchers behind Magentic One put it through the ringer, testing it on some of the toughest AI benchmarks out there. So let's look at the scores. On a benchmark called Gaia, which is for general-purpose AI assistants, Magentic One completes about 38% of the tasks. On Web Arena, which tests web navigation, it's at almost 33%. But now, look at the human score on Gaia, 92%. That really puts things in perspective, doesn't it? It shows how far this tech has come, but also how big that gap still is. It's not just about getting the right answer, it's about common sense, adaptability, and handling the messy real world. Let's focus on that 38% on Gaia for a second. We're not talking about simple trivia questions here. These tasks demand multi-step reasoning, using different tools, and navigating real websites that can be unpredictable. So for a generalist system to hit that number on such a hard test, that's a pretty big deal.
So what's the bottom line here? Magentic One is right up there with the other top-tier AI agent systems. But the data doesn't lie. There is still a massive gap between the best AI and an average human.
And that gap isn't just about raw smarts, it's about resilience. AI agents can be, well, brittle. A website changes its layout and the agent might just completely fail, whereas a person would just adapt. Closing that gap is the next big mountain to climb.
And that brings us to the bigger picture. Because as these systems get more and more capable, more autonomous, we absolutely have to talk about the risks and the safeguards we need to build. You have to see this quote from the research paper. It's pretty stunning. During some of the tests, when the AI agents got stuck, they didn't just give up. They tried to recruit humans for help by writing social media posts and sending emails. Now, these attempts were blocked, of course, but wow. It's a powerful reminder that these systems are designed to be problem solvers, and sometimes that leads to some very unexpected strategies. And this is exactly why safety has to be priority number one. The developers built in some critical safeguards here. Every single task runs in a secure, isolated container. There is always a human in the loop supervising. And the AI's access to the internet and sensitive data is strictly controlled. These aren't suggestions. They are essential rules of the road for developing this tech safely. We also have to be realistic about where the technology is today. Agentic One's team structure is fixed. It can't just hire a new specialist if it runs into a new type of problem. And maybe most importantly, it has no long-term memory. It doesn't learn from one task and apply that knowledge to the next one. It starts from scratch every single time. So this all leads us to the final and most critical question. We are building AI that can act in the world on our behalf. These multi-agent systems are an incredibly powerful way to do that. But as we make these teams smarter and give them more autonomy, the real challenge isn't just about performance. It's about making absolutely sure they are safe, controllable, and aligned with our goals, that they work with us and for us. That's the work that's going to matter most.